Thanks, Jenny. Like she said, my name is Connor Williams, and today I will be presenting my University of Arizona GIST capstone project. It's titled Development of a Citywide Tree Inventory for the City of Seattle, Washington. Just to go over the agenda of what I want to cover today during this presentation, I'll give a brief background on the project, how it came to be. And this is a very technical, methods-heavy focused project. So a majority of the time we're going to spend is focused on the technical steps taken. And that'll include examining the source data sets, the combined inventory schema, how I designed the model to create this combined inventory, and then how I converted that model from Model Builder to Python, and what tweaks I may have done after that. To kind of show you how the rubber meets the road, I will also be walking through an example analysis of how a user of this combined data set might use the data, and then I'll describe some next steps that have already been laid out for the project. So some project background. This was a project sponsored by the Seattle Department of Transportation to be executed by the Seattle IT GIS group. I am a GIS analyst that works for that group, and this was a project assigned to me just due to my background in forestry. So this inventory is really needed to prevent a time-consuming process that has been completed in the past of manually creating a combined inventory from multiple data sets. So the goal was to create a citywide tree inventory using data from contributing departments across the city, and then develop some tools for city tree managers to analyze the tree data for various applications with a primary focus on pest management. So again, this is very methods heavy, so let's talk about just briefly the technical steps that were executed to reach those goals. I had to do a lot of contributing data set schema reconciliation. When you have multiple people contributing their own data, they're not all stored in the same formats. Once that was completed, I needed to design a common schema that these source data sets could kind of slot into with a target schema in mind of what would be common across departments. I designed a model using ArcGIS Pro's Model Builder to prepare and merge the data sets. And Model Builder was a nice tool to do this with just because it lets you kind of tweak discrete parameters as you create it and run it and test. And then if it doesn't output what you expect, you can tweak that parameter again and try again. And then finally, when I had a model I was happy with, I converted it to Python script so that I could hand it over to a developer on my team at the city so that it could be implemented on a weekly refresh schedule so that the combined inventory would be sensitive to changes to the source data sets. So talking about those source data sets, let's get to know them a little bit more. There are 5 major departments at the city that track trees. They're listed here on the screen, and I will be giving a little cheat sheet here in the bottom right-hand corner of the screen to indicate what an acronym might mean if you're not familiar. But they're Seattle Department of Transportation, Seattle Parks and Recreation, Seattle Department of Construction and Inspections, Seattle Public Utilities, and Seattle City Light. And right off the bat, Seattle City Light really doesn't have suitable data for contributing to a combined inventory like this. When they track a tree, they're not really tracking the individual tree, they're tracking a work order associated with the tree. So an example of this might be a trim needed to cut a tree back from power lines. They're not tracking that individual tree through time, and a similar record might be created the next year after that. So let's start with SDOT. SDOT is the project sponsor, and they are the largest tree inventory across the city. At the time of measurement, just under 220,000 individual records, and their oldest records are coming from 1950. But I suspect that that's actually an erroneous default date value for a null value put into a date field. So it's a little fuzzy when this inventory started. Seattle Parks and Rec has the next largest inventory at just under 30,000, and they started tracking in 2008. Seattle Department of Construction Inspections has a large inventory, but they're a little bit of an exception. The previous two departments own and manage trees directly, but this is a permitting department, kind of a policy and regulation department. So they aren't tracking trees that the city owns and is responsible for, but rather what private landowners are getting permits for on their own lands. So it's a bit of an exception, but they had a robust inventory, so that it was decided to include them anyway. And then the final department that tracked trees actually has two individual tree data sets. The first one is fairly small. There's not a lot of trees associated with their infrastructure, but the larger of the two, this TFN planting location data set, is for their Trees for Neighborhoods program, where the department donates trees to private landowners to plant on their properties. And they started doing this back in 2009. So in summary, these source data sets, they're 5 unique data sets from 4 different departments, and there's more than 280,000 individual records across them, and this is growing every day. Some of them are fairly static data, others, the count changes day by day. And so now that we understand the common all of the contributing data, there was a series of interviews with the data stewards of those contributing data sets, and I performed some analyses to identify a common schema, and that's what you're seeing here on your screen. And I'll take a little bit of time to walk through this schema and point out some of its nuances. A big fraction of the schema is just metadata, right? It's individual IDs from contributing departments. It's information about what database this information is coming from. And this is really important when you're throwing a lot of unlike data into a common place so that you can trace back to where it came from. And some of them, because it's different databases being merged, have unique IDs that are no longer unique when they're thrown together. So it can be really tricky to track these things back. So we wanted to catalog this very, very carefully. Then there's a group of data that's really easy. This is stuff that can be copied pretty much directly from the contributing data. Some requires a little bit of tweaking. I used the example of, some departments track a status of a tree being removed and they capitalize all of the letters in the word, where others don't do that. So I had to do a little bit of tweaking with some Python and Arcade just to get it in a nice user-friendly, map legend-friendly format for users to interact with, but, very minor tweaks. The final bit of data that needed to be managed needed a little bit more work on it, really. So the scientific name field specifically is really important for city tree managers. If you know the scientific name of a given tree, that can inform you about what management you might need to execute on that tree. But some departments don't track that. They track common name instead. Like scientific name, genus is really helpful. Some pests are genus specific, not just individual species specific. So we can use this group of 3 fields to make inferences about the others. So that's very useful information that requires some careful handling. And then the condition code. Only 2 of our departments contribute any condition information, and they're very similar scales, except that Parks and Rec has one more step in it. So I needed to do some management of this data to make sure that the arborists understood what was happening to their condition code when it arrived in the final table. I won't spend too long here describing the process shown here on the screen. This is a screen capture of the Model Builder interface in ArcGIS Pro, but really there's a few discrete steps here. The first one for every contributing data set involves some data preparation. I make a copy of the data and then I manipulate that. So if it requires recoding or a new field to be calculated, things like that all happen at this step. And then the final step, just to create the data, I've got these temporary tables created, and I merge them into the target table with some appends as shown here. Python is not a super visually engaging item to show here in the presentation, so I won't spend too much time here either. But in ArcGIS Pro, you can simply export a model builder model directly to Python script. And from there, you can run it and get a usable product. But in order to make this friendly to the rest of the IT ecosystem that this would need to operate within, I needed to do some manipulation to make sure that if anything changes about the process, say a source data set changes its format slightly, we needed some error handling to throw exceptions so that the script wouldn't run and overwrite an old version of the combined view. You also want to add as much annotation and commenting in the script as you can. So if another user who's not seen it before gets their hands on it, they know what's happening and why. And then, like I mentioned, this is will be run on a weekly basis so that it's sensitive to changes in the source data sets. And that requires, calling different variables in a different way than ArcGIS Pro's native export would support. So to bring this home for you, the example analysis I want to talk about today is an Emerald Ash Borer triage map. So this is a view of the completed data set where I've done a query for all ash trees in the city. That's because Emerald Ash Borer, this kind of beautiful little guy here, is a invasive pest that's moving from the eastern North America west. We've even seen it in Oregon State in 2022. So tree managers in Washington State are very nervous that it's going to be coming to the area. And a map like this can help tree managers in the city really plan the work that they need to do if and when this pest arrives. And here we're just color coding by contributing departments. You can see there are some major thoroughfares through the city where most of the street trees along a given thoroughfare would be affected by a pest like this. So just to talk briefly about some next steps, I've created the data set. I'm working with a developer to get it on this refresh cycle. Next, I need to publish an internal and external view of the